Now guys, we're going to looking at this question here. It's the one I just uploaded, the 2020 Examcraft question. You'll see at the start there, they say in an experiment 4.69 grams of hydrated sodium carbonate, blah, 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 blah. That first bit of information we're not going to need until the very end. What we are going to need is this down the bottom. Okay, this bit. They tell us that the concentration of the acid was 0.13 molar and the volume of it was 20.17 centimeters cubed. That's the mean titration figure. And they tell us that they used 20 centimeters cubed of the sodium carbonate. Now, so to do the first principles, I've already, apologies if anyone is prone to motion sickness, I'm going to apologise in advance. So there's the balanced chemical equation. Always start with the balanced chemical equation. We have the concentration here of the HCl and we have the volume of the HCl. Now you'll notice that the first question is to calculate the number of moles in the 20.17. So this is C part 1. Okay, so they told us that it's 0.13 molar. That means 0.13 moles per litre, which means 0.13 moles per 1000 centimeters cubed. So what we need to do is put that into 1 centimeter cubed and then 20.17 centimeters cubed. So to go from here to here, we're basically dividing both sides by 1000. So 0.13 divided by 1 is 0.00013. Okay, and then to go from here to here, we're multiplying both sides as such by 20.17. So that's 0.0026 to make our lives easy. So that's 0.0026 moles in the, it's 0.0026221, so it's rounded off 0.0026 to make our lives easy. Okay, so there's this many moles in this volume. Okay, now the next thing they want us to do in C part 2 is to calculate excuse me, the number of moles of sodium carbonate in the 20 centimeters cubed. Right, so once you have the concentration of one species, you just go up here and you look at your ratio. Okay, so the ratio of sodium carbonate to HCl is 1:2. So if I have 0.00266 moles of my HCl, I should have half that amount, 0.00013 of the sodium carbonate. So it's it is 0.0013 moles in the 20 centimeters cubed. Okay, again, apologies for those of you who are motion sickness sensitive. I probably killed you. Now, so we know how much of the sodium carbonate is in 20 centimeters cubed. All we have to do for the last part is to bring it up to the concentration in moles per litre. So, as we know, so this is C part 3. Okay, so it's 0.0013 moles in 20 centimeters cubed. Well, again, we just go 1 centimeter cubed and then up into 1 litre, which is 1,000 centimeters cubed. Okay, so there is 6.5 by 10 to the 6 by 10 to the power minus 5 in 1 centimeters cubed. So then when you multiply that by 1,000, it's 0.065 moles in 1 litre. Okay, so that's part A. The next part then is they want us to convert it into grams per litre. So it's now for this part you don't need to worry about the water crystallization, because that actually doesn't react in the titration. So we just want to know how much sodium carbonate is present. We're going to worry about the D part in a couple of minutes. So all we do there is 0.065 multiplied by 106, which is the mass of sodium carbonate. So that's 23 times 2 plus 12 plus 16 times 3. So when you do that anyway, you end up with 6.89 grams per litre of sodium carbonate.